All right, you're also going to need your purple sheet today, because I'm going to show you where some of the things are on it that we need. But we're kind of just going through and refreshing our memories on trig. All right. How are we doing on getting this all written down? First period also asked me for the blank unit circles because they're like, so I uploaded my completed one from last year, and I color code it when I do it, so. I know. No, stop it. All right, can I scroll a little bit? Okay, thank you. All right, so I've got an initial example. All right, so for this one, and most of the time, I just do this anyway. And then second step is, I know sine, I know cosine, tangent. You don't have to put the theta necessarily. And I always write it next to, like, cosecant, secant, and cotangent. And the reason I do it that way, I'm flip crap because I'm kind of lazy. So I'm given that sine is square root of 5 over 5. Yes? Does that rationalize that denominator? So before it was rationalized, it would have equaled 1 over square root of 5. Okay? So I unrationalize it, and the reason people at home are like, what are you doing, lady? I'm air quoting this, unrationalizing it. The reason I do that is because if I flip this, do I have to rationalize it again? No. Nope.
Oh.
If you unrationalize it and then you flip it, you're good. Because I'm lazy.
This is why I checked out of my daughter's.
All right. The cosine they gave me was 2 root 5 over 5. So unrationalized, that would be 2 over square root of 5. So square root of 5 over 2. Now that you know all this stuff, like sine, opposite is 1. Hypotenuse is square root of 5. Cosine, I've got 2 over square root of 5. It's just one of those things to kind of help you to, number one, not make mistakes, but number two, be as quick as possible with it. So tangent is opposite over adjacent, so 1 over 2, just being 2. Easy peasy lemon squeezy. All right, ready to scroll? Now, these have a bunch of space. We don't actually need all of the space for this, so don't panic. All right, ready? How many of us are panicking because it says don't use a calculator, and you're like, but I don't know 20 degrees. It's not on the unit. All right, so upper left-hand corner of your purple sheet, you'll see reciprocal identities, okay? So what? Tangent, all right? And it just says theta on our fancy-dancy little sheet, right? So what is theta in this case? What's tangent of 20 minus tangent of 20? What did we say? 0. Ta-da! They're all ones and zeros for answers. So don't panic if you start getting ones and zeros. They're still legit answers. All right. This one, I've got 1 over secant squared. What is 1 over secant? Nope. Cosine. Remember, secant, it starts with an S. It doesn't match with sine. It matches with cosine. Because why would we make it? So this is cosine squared of the same theta. What is sine squared plus cosine squared? 1. All right, doesn't matter what's they're the same theta. If you add them together, you end up getting 1. All right. Do we want to do another of, if you're given info, fill in the circle and write out the 6? You just want me to fly through it real quick? If they tell you what the sign is. All right, so I got sine equals 1/3. Opposite hypotenuse. Here's my theta. Pythagorean theorem, so 3 squared minus 1 squared. Do we remember how to simplify down radicals? Yeah? Yeah, it's just square root of 8 is always 2 root 2. You'll tend to get pretty good at it. So this side over here is 2 root 2. And I used to do this so much. What is this? Cosecant, secant. That I used to have a stamp that would literally stamp like the 6 functions. That's 3. Cosine is going to be 2 root 2 over 3. So this will be 3 over 2 root 2. And then tangent is opposite over adjacent. And then this one just becomes 2 root 2. Yes, no, kind of, sort of. All right, so we're going to do the complementary angle theorems next. And honestly, the complementary angle theorem that they have in the book is literally just the cofunctions on your purple sheet. Okay? So that's your upper right-hand corner. All it says is that if you have sine, it's going to equal the cosine of 90 minus theta. Okay? 90. So, these angles add to 90. All right, but on your purple sheet, you see where it says like pi over 2 minus? It's just saying 90 minus. All right, ready? So, cofunctions, upper right-hand corner, sine matches up with cosine. Except if I have sine of 62, what do I need to have for the cosine? 28, yep. Need them to equal 90. That's it. All right. Cosine of pi over 4. Remember, this is 45 degrees. So sine should also be 45 degrees, so it's going to be sine of pi over 4. Now, the right-hand side got a little messy for people in first period. So, what would be 90 degrees if we're talking pi's over 12? Yeah, 6 pi over 12. So, 6 pi over 12 equals 90. So, if I have 1 pi over 12, and I need to subtract that from 6 pi over 12, how many pi's over 12 do I now have? 5 pi's over 12. Same thing down here with this one. Halfway would be 3 pi over 6. So that would make this 2 pi over 6, but let's be honest, stupid textbook's probably going to freak out. But that's not too bad. All right, last two and then we are done. What? Yeah, and the back hit me in the back of the head, and I ended up on my butt on the floor. And my middle schoolers were all like, what do we do? I'm like, first question is, are you okay? And they go, okay, are you okay? And I'm like, I am fine. And I said, second question is, can I help you? And they go, can we help you? And I'm like, someone get the And then third statement was, now you may laugh. And we all lost it. All right, ready to knock these two out? So, using your cofunctions, if I have secant of 28, and then I've got cosecant of 62, I know that secant of 28 needs to equal what? Cosecant of 62. So, these two stupid things are equal. Which one do you want to get rid of, the secant or the cosecant? Cosecant? All right, we don't like you. We're going to make you secant of 28. So what is secant of 28 minus secant of 28? 0. All right, and then same thing over here. If I have sine of 35, that 55, because that's how my cofunctions work. So if those are equal, you could just, I don't know, which one do you want to replace, the sine or the cosine?